Hi Wildcats, this is a review of Unit 2, Focus Question 4, where we will be looking at the speed of mechanical waves. I want to note right here at the beginning that although we'll use sound as an example frequently, these concepts apply to any mechanical wave. So sound wave, um, a wave like an earthquake wave, a wave traveling through the water, all of these things, any mechanical wave or wave that requires a medium is going to be follow these principles. So we actually need to review with a little bit of chemistry here. If we look at the different states of matter, there's some things that hopefully we recall. Solids, liquids, and gases are the three states of matter that we're most familiar with. Gases, what makes them different is in gases, the particles are free to move around and they move around quickly and they're far apart. In a liquid, they're somewhat bound and closer together, but they can still move around. And in a solid, they're typically locked together in a really rigid pattern. And so, since we'll talk about sound here, sound is a longitudinal wave, like we've seen, and there are these areas of compression. And so the reason that sound travels different speeds in different mediums is because, and mechanical waves in general, is because the closer the particles are, the faster that energy can be transferred through the medium. So, I mean, if we look at this picture here where the sound wave is moving from left to right, you can see the wave, this area of compression, is literally the particles bumping into each other, and then that transfers from these to this, and on and on and on. And so if we just stop and kind of think about it, the closer those particles are, the easier it is for that energy to transfer from one particle to the next. So in gases are the particles are just randomly flying around and bouncing off of each other. And so since they're farther apart, it's going to take longer for that energy to transfer from one particle to the next. Whereas in a solid, it'll happen much quickly, and a liquid somewhere in between those two. A kind of an analogy that you can think through is like if you were like passing a baton. If the people are standing right next to each other, it's really fast to pass a baton because you don't have to move. Whereas if everyone's 10 meters apart, there's that time where you have to run in between to get the baton from one person to the other, and that's going to be a slower or take a longer amount of time. And so therefore, it would be faster. Where people separated from each other would be similar to a gas, and people lined up right next to each other, just passing the baton from person to person, would be like a solid. Okay, if we had a picture over here where there was no medium, so no particles flying around, then you would have no mechanical wave, right? Because mechanical waves, one of their properties is that they require a medium. And this is why the energy has to be passed from one particle to the next. So in a vacuum, if there were a box over here that was empty that said vacuum, if there are no particles, the energy can't be passed. And that's why one of the first things we learned is mechanical waves require a medium. Well, this is why. Okay, and I said this at the beginning, sound that we used here is just an example, so this is true of all mechanical waves. Okay, there are a few variables that affect the speed of a mechanical wave in a medium. Uh, we're going to assume that the wave speed in a medium is constant, which it is. That can change slightly. Like if you change the temperature of the medium, it can change uh, how fast the wave travels. That's because temperature is a reflection of how fast the particles are moving around. So sound actually travels slower, waves travel slower in colder temperatures because the particles aren't moving. In faster air temperature, the particles are moving around faster and bumping into each other more frequently, and therefore it's easier to transfer that energy from particle to particle. Tension is another thing. We've done this in springs with the springs in class. If the tension changes on that spring, that can affect the speed of the wave, even though the medium is still the same. So there are some things, but we are going to assume that in a given medium, the wave speed is constant. Okay, there is one area or one time where wave speeds always changes, and that is when it moves from one medium to another. And we'll look into this further in focus question 6, but here is a wave. You can see it's traveling. When it moves into a medium, its properties change. So this is medium A. So let's say this is air. So it's going from air into solid. You can see the wave's properties change, and then when it leaves the solid, its properties change back. So we'll take a much deeper dive into this when we look at focus question 6, but for now, it's just important to understand that uh, we can change the speed of a wave by the movement or by the medium that it's in, and by changing from one medium to another, that can speed up or slow down a wave. So an example of this would be like if you had you're on a desk or you're knocking on your desk, the speed would be traveling faster through the table, and then when it vibrates the air around the table, that speed would slow down, or the sound would slow down. And so that would be an example of it. And as I said, for right now, if you just understand the basics that a wave speed changes when it moves from one medium to another, you're good. And then we'll take a deeper dive in this in focus question 6. I want to encourage you here to take a look. There's a video that Mrs. Griffin and I made of wave speed in 3 different mediums where we use dominoes to show this principle. That is worth a look as well as you put together your notes here, as it is a really good example of just actually seeing that how close the particles, or in our case dominoes, are actually really does affect how fast the wave speed travels. And that is in the learning resources as well. So I hope this helps as you put together your notes for focus question 4.